Hey math friends, this is Precalculus section 6.3 day 2 notes. We are going to start by talking about trigonometric functions of angles. In chapter 5 we learned the reciprocal identities and the Pythagorean identities with respect to t. These identities are the same identities if we're calling our angle theta instead of t. So sine of theta, reciprocal identity, is going to be 1 over cosecant theta. Reciprocal identity. Cosecant theta would be 1 over sine theta, and tangent theta would be sine theta divided by cosine theta. Cosine theta would be 1 over secant theta. Secant theta would be 1 over cosine theta. And cotangent theta would be cosine theta divided by sine theta. Of course, we can also write tangent as the reciprocal of cotangent, so 1 over cotangent theta, or cotangent can be written as the reciprocal of tangent, so 1 over tangent theta. However, most of the time we're more interested in looking at tangent and cotangent as either sine over cosine or cosine over sine. And then we have our 3 Pythagorean identities that we learned in chapter 5, cosine squared theta plus sine squared theta equals 1. As you know, that comes from the equation for the unit circle. Sine squared theta plus cosine squared theta equals 1 is like x squared plus y squared equals 1. And then if we divide everything by either cosine squared theta or by sine squared theta, we create our other 2 Pythagorean identities. 1 plus tangent squared theta equals secant squared theta. That's what we get when we divide by cosine squared. And if we divide everything by sine squared, then we get cotangent squared theta plus 1 equals cosecant squared theta. Okay, so let's look at the next example. It says express cosine theta in terms of sine theta, where theta is in quadrant 3. So the first thing is quadrant 3 tells us about the signs of sine and cosine. And in quadrant 3, we know that sine theta and cosine theta are both negative values in quadrant 3. Okay, so when we get to our answer, we know we're going to choose the negative one for that reason. If we want to express cosine theta in terms of sine theta, then we want to use an identity that has cosine in it and sine in it. So the identity that I'm going to start with is my first Pythagorean identity. So I'm going to start with cosine squared theta plus sine squared theta equals 1. And if my goal is to express cosine in terms of sine, what that means is that when I'm done, I want cosine theta equals something with sine theta. So I am trying to get cosine theta alone. So obviously my first step here is going to be to subtract sine squared theta over to the other side of the equal sign. So I'm going to have cosine squared theta is equal to 1 minus sine squared theta. And then if I want to solve for cosine, I am going to be taking the square root. And as I know, when I take the square root, I'm always going to get a plus or minus. Okay. And we know, because we're talking about the third quadrant, both sine and cosine are negative. So cosine is definitely negative. So we are going to choose the negative. Cosine theta is going to be equal to the negative square root of 1 minus sine squared theta. Now, I know some of you are thinking, well, can't we simplify that sine squared because it's under the square root? No, you cannot, because we have to follow PEMDAS, and PEMDAS says that you would do any operations under the radical before you would perform the square root. So we first have to square sine, then subtract from 1 before we would square root. So think of that 1 minus sine squared under here as being a family. Okay, you can't cancel the square root and the squared because that 1 minus sine squared theta is a family. In my second example, they tell us that sine theta is 2/3 and theta is in quadrant 2. They want us to find cotangent of theta. All right, well, we're going to begin with the fact that theta is in quadrant 2. Since we're trying to find cotangent, okay, cotangent is cosine over sine, and in quadrant 2, we know that cosine is negative and sine is positive, which means if we're dividing a negative by a positive, the result is going to be negative. So we're going to begin with writing that down first, just because we're going to need it at the end. We know that cotangent is negative in quadrant 2. So we're going to be choosing the negative answer when we get to that point. Okay, they tell us that sine theta is equal to 2/3, which tells us that cosecant theta, its reciprocal, would be equal to 3/2. Okay, if we want to find cotangent, then we need an identity that has cotangent in it. So I'm going to use the Pythagorean identity. That is cotangent squared theta plus 1 is equal to cosecant squared theta. And I'm going to be solving for cotangent. So the first thing I'm going to do is I'm going to subtract the 1 over to the other side. So I'm going to have cotangent squared theta equals cosecant squared theta minus 1. Then I'm going to square root both sides, right? So when I do that, I already know that I'm going to be choosing the negative, right? So it's going to be negative square root of cosecant squared theta minus 1. And again, think about the fact that this is like a family here underneath my radical. But I'm not done with this yet because I was given the value for sine theta. I know sine theta is 2/3, and I know therefore that cosecant theta is 3/2, so I can actually substitute that in under my radical. So my last step here is going to be that cotangent theta is going to be equal to negative, and then I've got cosecant is 3/2, and I need to square it. So 3/2 squared minus 1. That's under my radical. So I have to follow PEMDAS. First, I have to square 3/2. That's going to give me 9/4 minus 1. And 9/4 minus 1 would be 9/4 minus 4/4, which is 5/4. And I can simplify that a little bit because I can do the square root of 5 over the square root of 4. So that's going to give me negative square root of 5 over 2 because the square root of 4 is 2. So there's my answer. Given that sine theta is 2/3 and theta is in quadrant 2, the cotangent of theta would be negative square root of 5 over 2. In example 3, we are asked to find the values of the trigonometric functions of theta from the given information. We know that sine of theta is 3/5, and we know that we are in quadrant 2. So the first thing that I'm going to do is I am going to draw a right triangle in quadrant 2. So there's my right angle. Here's theta. I know that sine is 3/5, and I know that sine is opposite. So 3 over hypotenuse, 5, okay? Now, if you know your special triangles, you know your Pythagorean triples, you know that if one of your legs is 3 and your hypotenuse is 5, then the other leg of this triangle has to be 4. But since we are looking at quadrant 2 here, we know that our missing x value has to be a -4, okay? So I'm going to put a little note here so when you're looking at this later, you remember. Must be negative because it's in quadrant 2. But this is a 3, 4, 5 right triangle. All right, so now that we have that information, we can go ahead and find our 6 trig values. Cosine theta is going to be adjacent over hypotenuse, so that's going to be negative 4 over 5. Tangent theta is going to be opposite over adjacent, so that's going to be 3 over negative 4. Cosecant theta is going to be the reciprocal of sine, so if sine was 3 over 5, cosecant is 5 over 3. Secant is the reciprocal of cosine, so that's going to be negative 5 over 4, and cotangent is the reciprocal of tangent, that is going to be negative 4 over 3. Okay, now there is another option for this problem. Option number 2 would be to use our Pythagorean identity, sine squared theta plus cosine squared theta equals 1, to find cosine theta. That's just another way to do this problem. If we're given sine, we could plug that into the equation, solve for cosine. Once we know sine and cosine, we can figure out all of our trig functions from there. I'm not going to show the work for that, just letting you know that that's another option for this problem. Okay, the last thing that we're going to talk about today is a new formula, okay? Here's a triangle. We're given 2 sides. We're given A and B and the included angle theta right here. And that's important to note that theta is between the 2 given sides. We know that the area of any triangle can be found by taking 1/2 times the base of the triangle times the height of this triangle. Well, if we look at this particular triangle right here, the height of our triangle is h, right? And the base of our triangle is a. Okay. But we also know that the sine of theta from our picture, if we look at theta, the sine of theta is the side opposite over the hypotenuse. So the sine of theta is going to be h over b. Okay, so that tells us that we could actually rewrite the height of the triangle in terms of b times sine theta. So now we're just going to take that and we're going to do a little substitution here to create our new area equation. So the area of triangle WTH can be found by taking 1/2 AB sine theta. Okay, so a little note here. Area equals 1/2 AB sine theta is the area of any triangle with side lengths A and B and included angle theta. Got to make sure that angle is between sides A and B. That's the most important part. So for our last problem here, they want us to find the area of this triangle. So let's make sure we have the right information. We have a theta, and we have that angle being included between 2 given side lengths. So we can go ahead and use our new formula. Area equals 1/2 AB sine theta. So 1/2 times 13 times 24 times the sine of 35 degrees. You grab your calculator, make sure you're in degree mode. You plug that in and you get that the area is 89.48. Since we weren't given units here and we're finding area, we're just going to say that our area is in units squared. And that's it.